Welcome back. Today we're going to talk about polar coordinates and the notes. Now here's the thing about polar coordinates. Polar coordinates are different because normally we go with an XY. Right? Right, left, up, down. Okay? This is our normal. In polar, it looks like this. R and theta. Okay? And when we do this, basically, we are graphing, and this is going to blow your mind, right? This is a distance and an angle. Okay, so when we look at distance and an angle, we are talking about how much do I open around, and then how far do I go out? And so in polar, really it's not left and right, up and down, it's around and how far away from the pole, okay? Here's an example. Here's the pole. And my distance is r, and if this is the positive x-axis, this is the polar axis. This is my theta that it opens up, right? And so this point right here is r comma theta, meaning it's r away from the pole and theta open. And so this polar axis and the pole are combined, so everything is from that center, and so it opens up theta and goes r away from the pole. So when we plot the points with the given polar coordinates. Here we go. Here's our theta. And here's our radius. This is what it looks like. You ready? Open up pi over 3. And this is going to be too long. And so our point is 2 comma pi over 3. Now that doesn't seem significant. It looks like the picture we just drew. But let's look at what happens here. In this case, we're going to and you want to open up to your angle first and then talk about your radius. So check this out. 3 pi over 4, where is that? So if you think about, your unit circle right here, if pi is over here and this is pi over 2, 3 pi over 4 would be right here. Well, think about this for a second. I have my positive axis, my polar axis here, and this is my 3 pi over 4, right? But because this is -1, what does that actually mean? This would be 1, and so it would be out here, but -1 puts it as a reflection down this way. And so here's my point of -1 comma 3 pi over 4. And so anytime you have a negative, it's going to have this little tail reflected over. So do your angle first, then your radius. All right? This case, -45 degrees. So -45 degrees is down here. This is 45 degrees. And our radius will be 3. And so our P here is 3 comma -45. All right. Angle first, then radius. So if the point P has polar coordinates of this, find all polar coordinates for P. So what does this mean? Let's draw a picture. I'm going to show you. So it opens up pi over 3. So here's 3 comma pi over 3, right? What would be other polar coordinates? Well, if I remember that I'm dealing in like unit circle stuff, I could go around and have 3 comma pi over 3 plus 2 pi, right? Or plus 4 pi, right? So this would be 3 comma 7 pi over 3. Could be because it'd be like, 6 pi over 3 would be 2 pi. So I'd have 3 comma pi over 3 plus 2 pi times n, meaning just a number of times around, right? Or think about it like this. If I am at pi over 3 here, and this is 3, right? It could be a reflection back, right? It could be a reflection back. So it could be -3, so it'd be -3, so I'm somewhere out here, some undefined angle that I don't know, right? And then it would be a reflection back. So what if the x was negative? So this was manipulating the angle coordinate. What if I manipulated the x coordinate, the radius coordinate? So it'd be -3, and then what would be this angle over here? Well, it'd be on the opposite side, so 180 degrees. So it'd be pi over 3 plus pi, right? Because if I was over here and then reflected back, so this would be negative 3, comma, and this would be 3 pi over 3, so 4 pi over 3. And so any coterminal angles with that. So this is my first answer, right? 3 and pi over 3 plus 2 pi times n. Or I could have negative 3 and 4 pi over 3 plus 2 pi n, because it could be any of those angles that are coterminal with that one. Okay, so it'd be on the opposite side and then reflected back. Always do your angle first. Okay, so you can do that for this one as well. So here's a coordinate conversion. Let P have polar coordinates of r theta and rectangular coordinates x, y. So x is always equal to r times the cosine of theta, and y is equal to r times the sine of theta. Those should look familiar. And so when we convert, all we're going to do is a couple of little operations using the unit circle, right? So if x is equal to r cosine theta and y is equal to r sine theta, sometimes the problem is if I have x and y, I've got to remember this too. Okay, so x squared plus y squared is equal to r squared. And an angle conversion, so tangent theta is equal to y over x. So that's another thing that we can use to find the angle. So this way, we can either have the polar coordinates and go to x, y, or have x, y and go to polar coordinates. All right, so here we go. Let's convert. My polar coordinate is 3, comma 5 pi over 6, and then want us to use an algebraic method to find the rectangular coordinates of the points with the polar coordinates. Approximate exact solution values with a calculator when appropriate. So if x is equal to r cosine theta and y is equal to r sine theta, and this is r and this is theta, x comma y is going to be equal to 3 cosine 5 pi over 6 comma 3 sine pi over 5 pi over 6. All right? And so what happens here? Well, this is 3 times square root 3 over 2, and that's negative, comma 3 times a half. Okay? And you can see if they wanted an exact solution, this would be 3 root 3 over 2, and that's negative, comma 3 over 2. Okay, and we could approximate that to 2.60. Keep doing that, forget the negative. Negative 2.60 and 1.5. Okay? All you got to do is put it in. Find your radius, find your cosine of your angle. Okay, so here is what gets a little bit more, a little bit trickier. Okay? I've got the rectangular coordinates, and I want to find the polar coordinates. So if x is equal to negative 1 and y is equal to 1, I need r, which is x squared plus y squared, the square root of, right, because r squared is equal to x squared plus y squared. And theta, we're going to use, and I'm putting an arrow because it's not equal to, but the tangent of theta is y over x. So let's do a little bit of conversion. So if r is equal to x squared plus y squared, the square root of negative 1 squared plus 1 squared is equal to the square root of 2. And so that's plus or minus, right? So equals plus or minus root 2. And the tangent of theta, so I'd do inverse tangent of negative 1, because that would be 1 over negative 1. And that could be equal to my angle. Okay, so when I do the inverse tangent of 1, what could I possibly have? Well, I could have a bunch of different angles, right? So if I think about my unit circle, these are where my tangent is going to be 1, and so where would it be negative 1? Well, it's not this one, and it's not this one, so it's either 135 degrees or negative 45 degrees. And so let's think about how are we going to find this? So if my radius is plus or minus root 2, what could it possibly be? Well, if it's over here, let's think about this for a second, okay? It's going to be negative square root 2. So we've got to think about it like this. We've got the possibility for our angles where the tangent is negative 1 could be pi over 4, or it could be negative pi over 4, which is this one down here, or it could be 3 pi over 4. So think about it like this. The only place where tangent is 1 is at my 45s, right, of each quadrant. It can't be either one of these because tangent would be positive 1. So it's one of these two angles. But you got to think about this for a second. Okay, so I now have a bunch of options, right? So I've got my radius is equal to plus or minus root 2, and my theta is equal to negative pi over 4 or 3 pi over 4. So it seems like there's a bunch of combinations, but I want you to think for a second. The point is negative 1, 1. Okay, my point is here. And so the only possible combinations that could go there would be 3 pi over 4 and root 2. How do I know? Well, it would have to be root 2 from the pole in the 3/4 pi angle. Or if it was negative pi over 4, so if it came down here, to get back to negative 1, 1, you'd have to go in the opposite direction. So the radius would have to be the opposite. So I'm moving in the negative pi over 4 direction and reflecting back up here, or I'm moving in the direction and staying up there. Okay, so those are the things you have to really think about. So these are my two possible points. Okay, the next, that's the trickier example. Let's do this example over here. X squared plus y squared is equal to r squared. And so that's 3 squared plus 0 squared is r squared. So 9 is equal to r squared. So this would be r is plus or minus 3. And so if I have that, and my theta is tangent inverse of y over x. So the tangent inverse of 0, that would be where my theta, or sorry, where my angle is equal to 0. So my only possible solutions would be pi. Okay, so if I think about it in terms of my unit circle, theta of 0 would be the y is 0, right? So that would be here, or 2 pi, right? But I know that 2 pi, that's not going to give me negative 3, 0. Negative 3 zeros over here. So it's got to be pi, and then it's got to be 3. So 3 and pi. Okay? Also, I could have, think about it like this. Negative 3 zeros over here. So if I go pi around, my radius would be 3. If I'm here and I reflect back, it would be 0 for my angle and negative 3 as my radius. So you got to think about, how do I get there, my angle and my radius, to be at that point? Or how could I be exactly opposite of it, so pi away, and then reflect back to it? All right?